Welcome aboard NASA Tours. My name is George Herman. We'd like to bid you a warm welcome to the John F. Kennedy Space Center. During our tour today, we'll have recorded commentary, and at times I'll stop the tape to answer any questions you might have. For those of you with a camera, anything you see you may photograph. Now, smoking is not permitted on our bus, so let's just settle back and relax, and we'll begin our trip with the Western world's first spaceport. Cape Kennedy, formerly called Cape Canaveral, was selected as a site for testing ballistic missiles, and later as our nation's first spaceport. As our space program grew, the site was extended to include Merritt Island. One of the reasons this was an ideal site is that the first stage of a rocket doesn't go high enough to go into orbit. And when it falls back to Earth, we'd rather it fall back in the ocean than over inhabited areas. Another reason is, from this point, we can take advantage of the Earth's rotation in achieving orbit, and also the islands stretching southeastward from the Cape were a ready-made chain of stations for our tracking network. Here at Merritt Island, there are more than 88,000 acres of land, of which 3,000 acres are orange groves and 39,000 acres have been left as wildlife preserves. We have wild boar, armadillos, alligators, 13 bald eagles' nests, and more than 200 separate species of birds, and even one reporting of a panther. The long white building on the right is the Manned Spacecraft Operations Building. Here is where we receive and check out the Apollo spacecraft and the lunar modules. And if you ladies think you keep your house clean, well, you should see the inside of this building. The walls, the ceiling, and even the floor is painted white, and they never stop vacuum sweeping. If you're just entering the room, you can wear regular clothes. But before you can go near one of the spacecraft, you have to put on white gloves and a special lint-free gown, like a surgeon would wear in an operating room. They even wash the air that goes inside the spacecraft.
97.2 microns.
Okay, good.
In other buildings, they assemble the scientific, communication, and weather satellites, and the surveyor spacecraft. For you folks who don't know what a surveyor is, that's an unmanned vehicle, and we've already soft-landed 5 on the moon. You've seen the pictures they send back. The last 2 even had claws which dug at the surface, scooped up the soil, and then sent a message back to Earth to tell what kind of soil it was. One reason for all of this is to make sure when our astronauts get to the moon, they got a pretty good idea of what to expect. While all of this is going on, the astronauts are practicing every detail of the flight. To help them do this, they have a trainer that is just like a real spacecraft, where they can simulate everything from the actual blast-off, complete with sound effects, to a docking in space.
Key started, and no P11. Okay. T-Mark, go check that. Roger. 5, 4, 3, 2, 1.
All right, lift off, clock started. Roll commence.
Roger.
Engine's tracking.
Roger.
Roll complete.
Roger. Say again.
No strain, let it go.
Roger. Rate change.
Roger, rate change, and we're venting.
Pressure's decreasing.
1 minute.
Okay. Aux dump RCS command.
Very good.
Command module RCS propellants on.
Very good.
Roger, switching.
How far do you think that building is? Anyone like to take a guess?
1 mile?
Anybody else?
Closer to 2 miles.
A mile and a half?
That's the vehicle assembly building. And from here, it's 5 miles away. Now we're going inside and have a brief rundown on what takes place inside the building. The size of this structure, folks, is again deceptive because we don't have much on our flat terrain to which we can compare it. The best way I know to get the full impression of its height is once you get off of this bus, get your feet firmly planted on the ground, just lean your head back and look straight up. Every once in a while, we'll have someone from New York to remind us that the Empire State Building is just a little bit taller than this. This we have no quarrel with. The Empire State Building about 2 times as high. However, if we cut the Empire State Building up, we could get nearly 4.5 Empire State Buildings in the walls of this one.
How much did it cost?
$160 million, ma'am. The Saturn V rockets you see in this building are not manufactured here. They're made in many different parts of the country, California, Louisiana, Alabama, and brought here by barge in some of the biggest cargo airplanes in the world. Now that you've seen the size of some of our rockets, you can understand why we must have a big building to put them together. 4 rockets, each 36 stories tall, can be assembled here at one time. When this building was under construction, clouds actually formed under the roof and it rained inside. The giant fans have been installed that keep the air moving so this can't happen. Once all the individual stages are checked out, they're moved into place with an overhead crane. The Apollo Saturn rocket consists of 5 sections, each stacked on top of the other. The main booster, the intermediate stages, and finally the payload that contains the spacecraft that will orbit the moon and the lunar module. It will take 2 men down to the surface and then bring them back again. When the rocket is assembled and all the systems checked out again, they open the doors at the side of the building. The doors are made up of sliding panels, each panel weighing 30 tons, and it takes 45 minutes to get them open. Then a large crawler transporter, which is like a giant tractor, is driven into the building and lifts the rocket, platform and all, to take it out to the launch pad. And they usually start early in the morning because it takes all day to get there. It's over 500,000 miles to the moon and back. The first 3 miles of that trip is made right here on the road out to the launch pad. The road out to the pad isn't a divided highway, but 2 road beds filled with loose rock to help cushion the weight. When the crawler transporter is carrying the mobile platform with the Saturn rocket, there is a total of 18 million pounds moving along at a top speed of 1 mile an hour. When the crawler is empty, it can really scratch off. It can double its speed and go 2 miles an hour. We had 2 gentlemen from Texas out here the other day, and one of them looked at those crawler transporters and said, "Hey, Tall, when we get back to the Big D, for you folks who don't know what the Big D is, that's Dallas. Remind me to buy one of those things. And the other said, what in the world would you do with one of those? And he said, I'd put a blade on it and mow my lawn. Our Saturn V rocket, when it's completely assembled, stands 364 feet tall, weighs 6.2 million pounds, and most of that weight is fuel. When this rocket leaves here, it will lift off with a thrust of more than 7.5 million pounds. This is about 180 million horsepower. That's more horsepower than a string of cars lined bumper to bumper from here to Seattle, Washington. Now from here you can get a good view of the roadway going up the top of the launch pad. Remember, that crawler transporter must traverse this grade with the Saturn V rocket. There are automatic leveling devices to keep the rocket level, so it doesn't become top-heavy and fall over. We're test launching these rockets right now in preparation for a launch to the moon. But it's more than a moon rocket, folks. It will do that job and whatever else this country needs to do in space for a long time to come.
Okay, are there any changes to the schedule, Arnie?
Line item 7, which is shown for all day, all of first shift Tuesday. The tank pressurization test will not start until 1300.
When do you want to run the leak check?
First shift Tuesday.
Arnie, you're going to extend that time out for 5 hours by cutting it off in the front end of that LH2 storage tank pressurization.
Negative. The hazardous portion of that test should last only about 4 hours, Ted.
Time check coming up on Apollo Saturn count. T-minus 8 hours.
C4. CUSW, verify ESE, LVDA, and the ESE position.
CUSW verified.
CLGK, request and execute FT-43.
CLGK, copy, will comply.
CLTC, CVTS on 121. TMS.
Ground switch open.
CLTC, TMS here. Go ahead. Somewhere here. ETMS. ETMS here. Would you start tape recorders? Tape recorder started. Okay. All personnel terminate all demons and function executors. Go ahead, CVTS.
Carry on.
You verify you're ready to pick up the con at T-minus 6:30 in about 13 minutes? Stand by. I'll get that information for you. All TC, channel 121.
50 kW.
We're now beginning to pressurize the tanks within the Saturn V vehicle. We'll pressurize all of the tanks in all three stages with gaseous helium. As the pressurization builds up, it's being monitored here in the control center now at 1 minute and 40 seconds and counting. Our status board still indicating all is well. The status board shows instrument units, spacecraft, and all the launch support operations well at this time at 90 seconds and counting. Houston flight now confirms that they are go for the flight, as are all other aspects of the mission. T-minus 1 minute, 16 seconds and counting. The pressurization continuing within the vehicle at this time. We also have a hydraulic commit that will permit the hydraulics to drive the engines in the first stage. Liquid hydrogen tank in the second stage now pressurizing. T-minus 60 seconds and counting. Our status board still shows we're go at this time. T-minus 50 seconds and counting. We have transferred to internal power. The transfer is satisfactory. The 6.2 million pound Saturn V launch vehicle now on its own power at 38 seconds and counting. To repeat, the ignition sequence will start at 8.9 seconds. We'll be looking for liftoff at 0. T-minus 30 seconds and counting. We'll count down from starting at T-minus 20. T-minus 25. Stage is reporting ready for launch. T-minus 20. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9. Ignition sequence start. 5, 4. We have ignition. All engines are running. We have liftoff.